Hello everyone again. Now we are continuing with our second speaker. Our second speaker is Denys Holovatyi. He is a founder of Osnova, a digital product company and data consultancy, enterprise AI, and an AI community technology messenger Munich. Denys builds digital products and data organizations for customers across Europe from the insurance, manufacturing, consulting, and educational sector. His talk for today will be the making of a data organization. Data teams often struggle to deliver value. KPIs, data pipelines, or ML driven predictions aren't inherently useful unless the data team enables the business to use them. Having worked on many data projects, Denys starting noticing some simple factors and summarize those in the operation model canvas and the value delivery process. In this talk, Denys will share some insights. Thank you. Denys?
Hello, everybody. Can you see and hear me well? All right, good. Then I'll just kick it off. Hello, everybody. Nice that you joined the talk. Give me a second to share my screen. All right, I'll just assume it's working. I'm gonna go ahead. My name is Denys, and today I want to talk about the making of a data organization. I would like to kick it off with a simple question, or maybe a situation that probably each and every one of you can remember and hopefully relate to. Maybe some project that you have been working for half a year on, maybe a year, and then you see it put into a drawer. Nobody ever uses it, or it stays in the local machine of your IT guy. That happens quite a lot in IT, especially in the data space. According to Gartner, 85% of data projects never see the light of day. Basically, it means they are never being put into production. And this is the thing that makes me personally really sad. And you might ask, well, Denys, how do you know and why we are supposed to listen to you? So a couple of words about myself. I have worked in the space of data science for about 6 years now. Have seen and built many teams, some of them successful, some of them not so much, especially for my customers. Customers vary in size between 1 million, 50 billion in revenue across manufacturing, insurance, recruiting, consulting, education space, and so on. So it gives you a little bit of a perspective that customers that I've had are pretty different. Also, you might imagine that their needs and ideas for projects were quite different as well. And it gave me, I think, a pretty good holistic overview of how data projects can be run. Couple of points about myself. I'm the co-founder and head of delivery at Osnova GmbH, my most recent company. We build digital products for customers, and about 2.5 years ago, I started my first business, Enterprise AI Consulting, where I consult customers on data analysis, data strategy, as well as implementation. And I've been involved in the AI community in Munich, especially for about 6 years now with my meetup group. A couple of words about myself. As I said, we don't need to go too much more into the detail. You can also check out my LinkedIn profile if you wish to. But let me jump straight into the contents. I hope you know a little bit now who I am, and hopefully can jump into this information with me. So let's talk about the typical hurdles of a data science project. Why do projects fail? I'm pretty sure you know all of those, but let's quickly jump through them. Well, sometimes you just have no data. Sometimes you are not able to create what I call consumable artifacts for your business users. It happens also that objectives on the project change quite a lot and you lose the sense of direction and basically go nowhere. Maybe the adoption is pretty weak. So you build a solution, it's nice, it's actually working, it is in production, but nobody cares at the end of the day, and that's what counts. And also, more often than not, projects are mismanaged. This is the case, obviously, not only for data projects, so it's a general project management issue, let's say, but in the data space, I would say they're quite severe. Let's talk about those in detail, and those, let's say, would be our problem set, and then we'll look into the possible solutions. So sometimes you just have no data. Right, somebody tells you, hey, let's analyze material management data. We need to do something on our inventory or something like that. And again, I come a lot from the enterprise resource planning perspective, large organizations mostly. So this is one of the topics they're definitely interested in. And it happened in the last project that some of the workflows that we needed to analyze, basically pieces of a process, were just not being recorded. It was no transactional data being stored on those, which meant we had to kind of throw away the part of the insight that we could have gained from it. In some cases, you can't join the tables that you need, and sometimes there is nothing on the data in a certain field, let's say in the SAP system, that you are expecting, but for whatever reason, the company is not using that field or misusing that field for two different purposes, which is also quite common, or maybe has implemented some kind of custom field for that. And then at the end of the day, you just don't have the data that you need. In the case of not having consumable artifacts, there are a couple of things that are important here. Well, my slogan is like, don't make a marketer use a machine learning model, because most likely they won't be able to unpickle your Python model and load into their environment, because they have no idea how to install Python, how to use pickle, what is serialization, and so on and so forth. So basically, you need to create some kind of product, and AI on its own, the model that you've built, is not really a product in my eyes. At least you have to package it in some way and ship it, right? And when I talk about shipping, it's something that, I think about this pretty much as container shipping, in the way you package it in a box and you send it over to your business user, for example, and the user can unpackage it. And when they pull out your AI model, it has all necessary features and different settings and whatever they need to start using it in the form of an app, a tool, an Excel plugin, or whatnot. You also have to make sure that IT knows how to deploy it, right? You have to write some kind of API endpoint documentation. If it's not an API, then whatever technical documentation is required to help out your users and IT people to implement it. In the case of changing objectives, this is a more organizational thing, right? The first two are more technical. This one is more of an organizational problem that people face. For example, that's one of the cases I've encountered. You might be told, hey, let's analyze data from this department across these 20 different products, versus the scope is changing and you have to work across 5 different related departments in a product palette of 3,000 items. Not a selection or a sample of the products anymore, but the full product portfolio of the company. And in the first case, of course, might be an easy pilot project, which you can complete in 2 months or even less. The second case, it may take a whole year, and it would be a global implementation with, of course, growing project team and growing requirements and so on. Another big problem that faces data projects a lot, because again, people often don't understand. They think you're working on data. Why do you care if you increase a table from containing 20 products to 3,000 items? And I'm not saying those are lines in the tables. Of course, this could be much more lines if those are movements of the products and so on. But just increasing the scope, let's say the time for data validation increases as well. And if you don't do data validation, your results at the end of the day may not make any sense. And with increasing scope, obviously, you need to increase time for data validation by quite a bunch, as well as the organizational effort to kind of coordinate those 5 departments and put all of the stakeholders together. Another huge point is weak adoption, which is, again, not only specific to data products, but again, I believe is more severe for data products, because a lot of people without a background in data or statistics, probability theory, business intelligence, or any of the related disciplines, they often don't understand how data works. They might say, oh, there's already an Excel file we're using. We don't want to switch to your weird dashboards. Change is also very hard. And the bigger and more rigid organization is, the more difficult it gets. For example, pharmaceutical companies or financial sector companies are usually the most difficult to drive change, because they are heavily regulated, and every change usually has implications beyond just a small atomic data project that you're doing. Another problem is that, which is again common for everybody on the adoption, it's the money of the company, of the organization, not the people's money. So often they don't care if this money is being wasted because their bonus maybe doesn't depend directly on it, if they don't have performance-related bonuses, which most companies only have in the area of sales or marketing, but not, let's say, procurement or customer service. And of course, the most common one, very loved in Germany, where I live, we've always done it like that, right? There is pretty typical, especially for mid-sized companies, so-called Mittelstand in Germany, the small and medium-sized enterprises, to say, hey, we've been doing this for 20 years, like now we don't care what you're talking about. The next problem is mismanagement. And this one is probably the one that I love the most. You often hear, hey, let's align once again, or hey, who wants to do this task because roles and responsibilities weren't clearly defined in the project, or maybe we as a team keep working for the steering committee, instead of finishing a certain task that we need to do, and the steerco itself becomes a task which distracts from productive work. Or somebody wants to be in your daily meetings as well. Again, typical for many projects, especially severe in the space of data, because you need to often explain things from the ground up. Let's say why null values in a certain column are not great, or why having too many of them can completely destroy the consequences that you might have from a certain piece of data. All right, those are the 5 big hurdles, right? And as I mentioned, I tried to kind of summarize and go through the cause of them. And again, I was focusing on the organizational part, because again, this talk is called The Making of a Data Organization. It's not a very technical talk, again, on purpose, because there are a lot of talks, a lot of books that go through the technical side of the data science process, machine learning implementations, BI projects, and so on. I was trying to come from a more organizational perspective. So the causes that I have specified here are also from that area. In particular, alignment. So the data science projects tend to be very multidisciplinary and experimental in nature. Those of you who have worked with data, which I assume are many, know that oftentimes you have a data set, you have your, 50 columns, 10 million rows, and you have no idea what's hidden in there, right? Before you do the exploratory data analysis, you don't know which kind of problems you have with data. A lot of people don't understand this. They approach data science projects as they would approach any kind of software implementation, where usually you have clearly defined features. Usually those features are quite standard. So an experienced developer can also relatively precisely, let's say, estimate how long it's going to take. And of course, in software development, there are cases where an expected bug comes up, or some question wasn't researched enough, which also leads to delays. But the data science process is much more prone to those kind of things because of this experimental nature. So you need to align executives, functional business leaders, line workers, and the IT and data scientists to work in the same mindset. The second thing is the business need. Again, due to the poor understanding of what a machine learning model can actually do, for example, people often come from the perspective of, hey, we have a solution in search of a problem, people say, right? So you have a solution, some kind of vendor came across your door and knocked on the door of the CIO, CFO, CDO, and whoever chief executive officer is in this case, and those could be also quite many different places where data science is anchored, topic for another discussion. But you may come one day in your department, let's say as a procurement officer, and discover that you need to implement some kind of data science project without clear understanding, like, do you need this thing? Maybe you already have a tool that is solving the problem, because it's often being pushed from the vendor side through the executive, through the salesperson, and then being pushed top down to the people, which may not need it. Here, a simple solution, frankly, the standard product development lifecycle of a normal startup is the solution, which is sometimes very difficult to pull off in a big organization, though. And the last but not least point is enablement. I briefly mentioned it before. For your average marketer or procurement officer, they don't know how to use an advanced dashboard. They don't know what well, some of them do actually, but they may not know in detail what a probability distribution means, what an outlier means, when you can discard those outliers, when you actually need to look into those outliers, and, a bunch of things on the basics of statistics, on how to find insights and data, and most importantly, how to answer their own day-to-day operational questions with data. Those things need to be taught. Most data scientists don't consider this to be their responsibility, and it might be true. It may be the responsibility of the team lead data science or somebody who takes care of value realization in the project. However, there should be a person dealing with enablement on any kind of technical project, especially on projects of such experimental nature as data science projects assume. All right, let's jump forward. So what do we do with that, right? We described the problems. We looked a little bit into the root cause analysis of these problems. What could be the solution? So I want to present a couple of pieces of the solution, and then let's say kind of the concept that I came up with that's been helping me quite a lot in the recent projects. So the first piece is the alignment across the organizational hierarchy. I mentioned alignment on the previous slide, and very simply put, you have 3 levels of organizational hierarchy: strategy level, tactical level, and operational level. And you can think about this strategy level is chief executive officer, chief financial officer, and so on. Tactical level are heads of departments and head of teams who manage smaller teams between, I don't know, between 50 and 5 and 50 people, something like that. It depends on the organization, of course, vastly. So this is a very generalized number, of course, but I'm just saying mid-level management, basically, you can think about this like that. And the operational level are essentially people who do the work, line workers, right? Those who sit at the computer at their desk and work on, let's say, customer service request, or somebody who's trying to analyze how different cohorts behave on the web page of a certain customer, and so on. And what I mean by alignment, right? How those 3 levels are often very much disconnected. Like your average CFO has very little idea, practical idea, detailed idea of how their own employees, let's say in the accounts receivable department, are working day to day. They, of course, know it on a general level. They see the KPIs and so on, but seeing a KPI and productivity, oh, I work on so and so many invoices per day, doesn't really tell you much about the actual work. So on the strategy level, what needs to be done? Goals need to be set. Strategy for data science implementation, it could be a data strategy itself, a larger digitalization or digital transformation strategy, or a holistic company strategy that's being defined, and the topic of data needs to be part of it. A roadmap for implementation of different use cases needs to be defined as well. And it needs to be aligned as well with lower levels of hierarchy to know what actually people need. It should not come only from executives, but it has to be signed off by executives. And also things like prioritization and expectations about those use cases need to be defined. I, as a consultant, for example, I also conduct the data maturity assessment of the whole organization. On the tactical level, you need to define how the team works, right? Internal processes, when somebody sends a request, what happens, or how a new use case is being assessed, or how a project team from the technical side, from the data team is being put together, as well as understanding how this team works in context, because oftentimes it's not just one quote-unquote data team in the company. There could be a business warehouse team, data architect team, business intelligence team, machine learning department, innovation hub, and whatnot. And somehow they all need to work together on the overall topic of data and need to define it. You basically need to write up documentation and communicate how it works. And as well, team maturity is very important. Of course, more senior colleagues who have seen multiple projects being executed will be able to bring your maturity of your data organization much forward and help you build your team. And when I say help you build your team, I imagine yourself in the role of the head of data science, for example, in a company, or a head of a certain smaller data team, chief digital officer, project manager. There are different roles, let's say, that I want to address with this talk. For data scientists themselves, the most important thing is the operational one, because it's for us that, the data scientists that that program things and write Python, SQL code, and whatever your language of preference is, how do they act in the project setup? Which kind of roles and skills they need to possess for this specific project? Because a data scientist, a very broad term, as you all know. Sometimes it's a person who builds some reports in Excel. Sometimes it's a person who dives deep into creating generative AI models. And those are, as you understand, two completely different things. In any case, internal processes for that need to be defined, and in specific project communication as well. That's the first piece of the solution. Second piece is the process beyond just the technical implementation. As I mentioned, there are a lot of courses and materials and books and whatever that teach you how to implement data science in a certain field. Again, could be BI, could be a hardcore deep learning, how to implement it. But very few actually consider the context that you're acting in, because if you're working on your speech recognition module, for example, it depends vastly if you're working in a small scale startup, for example, that sells apparel, or are you working in a bank that is 150 years old. The actual solution, the code might be the same or very similar, but how you act in the larger context of the project is very different. And again, as I find, very little is being done or talked about this. So here, a very simple process, how I would approach a new project, for example, and I would like to present the details, but due to the time, we won't be able to go into too much of them. But this is, in the essence, what I call the value delivery process, how you as a data science team can bring something useful to the business. Very simple. Again, nothing too fancy on one hand, but you define the problem, you run a pilot project, you do user testing, pivoting, normal startup scene, right? You show value in some way, you have a go decision, you organize a bigger kickoff with the business, and then you roll it out. And the rollout itself consists, let's say, of a sub-process of modeling the data, building KPIs and dashboards or models, enabling the business to work with it and realizing the value. The difference between this process and your standard data science process is that this one contains different parts. It contains, let's say, the organization of the project, the management of the project, as well as the technical implementation of it, and fosters a more startup-like approach, even in a larger organization, because I believe that's actually the only way to make it successful. Third part of the solution, defining, combining skills and roles. Here we have multiple, such as business user, KPI expert, data scientist, master data manager, source system expert, and a couple of supporting roles like legal or controlling. And together, those very disparate, very different roles, they might constitute our data team. And on projects, the big problem is often that project is a temporary thing, right? You work on it for 3 months or 6 months. And oftentimes you don't actually have a project leader that has power to bring those people together or to tell them what to do. So you have to be very precise in how you define different skills and roles and how you combine them, so that this merger of people, each of them cannot work 40 hours a week on this project probably, but maybe just 5 or 10 or 20 hours, how this Frankenstein of a team can actually lead to some result. You need to be very clear in which roles you have to cover. Again, some projects do that. Most of them fail to understand what is needed for a data science project, like master data manager, for example, or source system expert, in which capacity they are needed, which questions they need to answer. In many organizations, this is extremely intransparent and takes sometimes months actually to figure out. So to bring this all together, we are, let's say, trying to close the puzzle, and the following, this one slide, I just want to present you a conceptual framework that I have developed in the last 2 years to work with my clients more effectively and try to bring their data science projects to more success and do them faster and generally make them reach the goal of changing something in the organization. And of course, to be very transparent, it doesn't always work, as nothing basically does. But that's the framework I'm using. So let me share it, and happy to share the feedback after the talk. So the first part, you need to create the data strategy. Again, on this high level, you need to define how the organization works with data, what global goals it has, what data science use cases it wants to implement. Does it want to be a leader in some data science space or not? and which kind of budgets are available to do the project. Second thing is the operating model canvas that has been mentioned in the very beginning. That's the framework, the thinking aid that I have developed that basically summarizes how a data team is supposed to look like. Its organizational structure, value delivery process, resource planning, information architecture, knowledge management, etc., etc. Specifically for a data team, let's say which kind of moving parts and components and assumptions it needs to kind of check mark. For the team lead or the CIO, as well as, of course, for the team as a collective itself, to understand what they're doing, how they're doing it, why they're doing it, for whom, the customer groups, and so on and so forth. Basically, it's based on the premise of thinking about the team as a little startup organization inside a bigger company. That's, let's say, the main idea, and let's say it comes from the business model canvas to some extent. I mean, the fields are very different, but the general idea of a canvas comes from that angle. And the last element, again, the operational element, is the project setup in context. That's a very important thing. It's not just a generic project plan, which everybody does, of course. It's those specifics, right? How to combine those roles to make a Frankenstein that actually works, which means not only writing it down, but also communicating it properly. Also meaning onboarding the people in the right time. Also means establishing training and enablement session, maybe even before the project starts, to create some kind of coherent picture for this 5, 10, sometimes 50 people working on your data science project, and create a joint vision for them to compensate for this temporary nature of the project. And this thing together, I call it SOUP, which is the abbreviation of Strategic, Operational, and Organizational Plan. And to cook the soup, you basically need these 3 elements: data strategy, operating model canvas, and project setup and context. Together, I call it data organization consulting. So basically, I consult customers on how to build the teams in this way. Yeah, that's basically one of the specialties that I have developed, and that I wanted to share with you, because I believe even from this short presentation, you can get a lot of keywords and marks and milestones that might help you think about this in a little bit of a different, more holistic way to have a perspective, again, through strategy, tactics, and operations of the company, and understand better which pieces you need to bring together to make this thing kind of coherent and work. And just to finalize, just one brief shot on the case study to show you like in which kind of context I've been using this approach. With one of my customer, a large insurance company, they had troubles with the claims management process. It was slow, customer satisfaction was low, and it was pretty costly. So, problems on many different fronts. We approached it from these 3 perspectives. First, we analyzed the different business processes that exist in the company, and for insurance value chain, product development, sales, and claims management are core. Claims were selected. We also tried to understand the organization, who is involved in working on claims, because again, it's usually not an isolated business process. A lot of departments are involved. And we connected to several global initiatives within the company on process excellence, and the so-called Claims 2.0 was a strategic initiative the company was working on. In terms of operating model canvas, we set up internal processes and process discovery, KPI validation, writing code, defined and built the data architecture. Well, it was actually built to a large extent already. Like, I didn't set up the Azure data lake, but basically just the data jobs from the tool into the lake. And we trained 2 data engineers basically to ramp up the resources in the internal team of the department. The project itself was actually pretty standard, right? You ingest the data, you develop dashboards. In this case, it was more of a BI-driven project. You generate some findings, you do root cause analysis, you train the business how to use the tool, and you develop action plan to mitigate inefficiencies. Again, some of this, such as finding generation, root cause analysis, enablement, action plan, is often not a part of a data science project, and I strongly advocate for making it a part of any data science project, because that's the only way to make it work, essentially. And the results, we identified a bunch of saving opportunities in claims reserves, developed a new approach in the first notice of loss, which is the first time you as a customer contact your insurer and tell them what happened. And also a lot of the cost drivers were identified, including cost categories and expensive claim times. That's, let's say, one of the cases and results that came out of applying this SOUP framework to a real-world business, real-world customer. With that being said, I will wrap up my talk. Thanks very much for everybody listening. Sorry if it was a rush pace. I was just trying to squeeze in a lot of information. Thanks for your attention, for your time, and I'm happy to take questions if there are any.
Thank you, Denys. This was a really interesting and useful presentation, and I believe it can help a lot to young entrepreneurs. Unfortunately, we don't have time for the Q&A session right now because we need to go to another talk. But thank you again, and I hope we will see in another DSC event.
All right, cool. Thanks a lot. Thanks everybody, and see you next time. Bye-bye.
Thank you.